Today we're going to look at how to do different operations with rational numbers. And we're going to start by taking a look at fractions. Some of you may have seen different fraction operations before, but we're just going to go through and make sure that we know what we're doing because this is something that we're going to have to be able to do on our own. Anytime we're going to add or subtract fractions, I'm going to divide this up here, we need what we call a common denominator. Now the word common means that we're going to have something that's the same, and the word denominator means the bottom part of the fraction. So anytime I want to add or subtract two fractions, I have to look and find a common denominator. So for my first two fractions here, I have denominators of 4 and 8. They're not the same, so I need to make them the same. You want to find the easiest common denominator that you can use. If you can easily turn one of the denominators into the other, I'd go with that. So I can easily get from 4 to 8, and we do that by multiplying by 2. If I multiply the denominator by 2, I have to also multiply my numerator by 2. So this now becomes 2 times 3 is 6 over 8 plus 5 over 8. Then we just add the numerators and keep our denominator the same. So we have 6/8, and then we have 5 more, so altogether I have 11/8. Now you can leave that as what we call an improper fraction, or you can turn it into a mixed number. So now I'm going to say, how many times does 8 go into 11? Well, I can take 1/8, and then once I take those 8/8 away, I just have 3/8 left. This works the same when you have subtraction. So go ahead and pause the video, see if you can find a common denominator, and then do the subtraction for this problem. Then select the correct answer in Edpuzzle. Alright, so the first thing we have to look at here is that we do not have two common denominators. The easiest denominator that we're going to be able to use that would work for both of these is 8, because all I have to do is multiply 2 by 4 to get to 8. So we're going to multiply both our numerator and our denominator by 4 and rewrite our subtraction problem. When we have this minus sign floating on up front, I'm going to assign it to the numerator just to make things a little easier. So 4 times 1 is 4, then we bring over the negative, so we have -4, and then 4 times 2 is 8. So I've changed that -1/2 into -4/8. Now we're going to subtract the 3/8. And we're dealing with subtraction with positive and negative numbers now. So remember, this is where we're going to use keep, change, change. So we're going to keep the first number the same, change the subtraction to addition, and change the last fraction from a positive number to a negative. And I'm going to keep that negative up top just to make things easier. Now we do just like what we did with the addition. We add the numerators, so -4 plus -3 is -7, and our denominator stays the same. So we end up with -7/8. For both addition and subtraction, we had this idea of the common denominator. I'll try to star that. When we move down into multiplication and division, we're not going to need that common denominator anymore. In order to multiply, we can't have any mixed numbers. So I have to take this value and turn it into an improper fraction. To do that, I'm going to set my negative aside and know that I'm just going to be dealing with a negative fraction. Then I do 2 times 1, which is 2, plus 1 is 3. So I have 3 over 2, and then we multiply that and do the same process here. So 5 times 2 is 10, plus 1 is 11. So we have 11 over 5. Now I'm going to look at the signs of my numbers. I have one negative number and one positive number. Even though the plus sign or the positive sign is not there, we know that it's a positive answer. So when I'm multiplying different signs, I know that my answer is going to be negative. Then we multiply the numerators and multiply the denominators. So 3 times 11 is 33, and 2 times 5 is 10. We can also turn that into a mixed number. So I say, how many 10s can I put into 33? Well, 3 times 10 is 30, so we have 10. Then we have 3 left over, so we have 3 over 10. And since this was initially negative, we take this and turn it into a negative number. Division looks complicated at first, but there's a small trick that we use to make it nice and simple, like multiplication. You may have seen this referred to as keep, change, flip. We keep the first fraction, change the division symbol into a multiplication symbol, and then flip the third fraction, or the second fraction, by taking what we call the reciprocal, where we take the denominator and the numerator and they switch places. So this is actually going to become 4/5, keeping the first fraction, changing the division to multiplication, and flipping that second fraction. It's still going to be negative, but now the 3 is in the numerator and the 2 is in the denominator. Go ahead and pause the video, see if you can find the product or the multiplication answer for these two fractions, and then select the correct answer in Edpuzzle. Alright, so we're looking at two fractions. We have one positive and one negative, so I know that my answer is going to be a negative value. And now, just like we did before, we multiply horizontally. So 4 times 3 is 12, and 5 times 2 is 10. Except, unlike last time, now we can simplify this fraction. So I have two even numbers, both divisible by 2. So we're going to simplify. Negative 12 divided by 2 is negative 6, and 10 divided by 2 is 5. So we have negative 6/5. But we can also rewrite this as a mixed number. So I can say, all right, how many 5s go into 6? Just 1. And 6 minus 5 is 1, so I have 1/5 left over. And we were originally dealing with a negative number, so it's going to be negative 1 and 1/5. We can also do similar operations with rational numbers. When we're dealing with decimals, you will, as you can see, have access to a calculator for something like this, so you can just type this into your calculator. We have 4.3 plus negative 2.6, and altogether, that gives me 1.7. You can think about money with this, and do you have more money when you have $4 or $2? Since you have more money with $4, that's not negative, we know that our answer is going to be positive. So here, we have 1.7. Remember what we did when we were subtracting and we had the minus, parentheses, minus? This was our jumbo plus. So I can take that and turn it into an addition problem. When I'm adding mixed numbers, I find that it's oftentimes a little bit easier to turn them into improper fractions and then add. So we're going to do 2 times 4 plus 1. So 4 times 2 is 8, plus 1 is 9 over 4, plus now 3 times 2 is 6, plus 1 is 7. So we have 7 over 2. Again, we need that common denominator. So I have denominators of 4 and 2. So the least common denominator, it's going to be very easy for me to get to, is 4, because I can just multiply both of these by 2, and we have our common denominator. So we're really going to have 9 over 4 plus 14 over 4. I add my numerators and keep the denominator the same, and we're going to have 23 over 4. But we can also rewrite that as a mixed number. How many 4s go into 23? Well, 5 times 4 is 20, so we have 5 4s, and then we have 3/4 left over. So either one of these could be our answer. Remember that when we multiply, we need to turn each of these into improper fractions. So go ahead, pause the video, turn these into improper fractions, and multiply. Then see if you can select the correct answer on the Edpuzzle. Alright, let's see how you did. So we're going to multiply. 10 times 2 is 20, plus 7, so we have 27 over 10, but that was negative, so we have to bring down our negative sign, times 9 times 3 is 27, plus 2 is 29, and this was also negative, so we have 29 over 9. Now when I look at my signs, I have two negative numbers. Because the signs here are the same, when I multiply, I'm going to get a positive answer. Now, these numbers are going to be a little big when I multiply them, but again, I'm allowed to use my calculator. I'm going to multiply directly across. So 27 times 29 is 783. Then 10 times 9 equals 90. We can leave this as the improper fraction if we want. Now, we just have to see if we can divide it. So if I look at this, I can play around on the calculator a little bit. I notice that 90 is divisible by 9, And if I add up the digits here, 7 plus 8 is 15, plus 3 is 18. 18 is divisible by 9, so this is also divisible by 9. So I'm going to divide each of these numbers by 9, and we're going to get 87 over 10. Or we can turn it into the mixed number. So I say, how many 10s go into 87? Well, I know that 8 times 10 is 80, so I have 8, and then we have 7/10 left over. So either one of these would be good for our correct answer. Remember that fractions just represent division. So this is really the same thing as -1 3/4 divided by 3 3/4. We just need to take these, turn them into improper fractions, and then we can use our rule. So 4 times 1 is 4, plus 3 is 7, so we have 7/4, but it's negative, divided by 4 times 3 is 12, plus 3 is 15, over 4. Now, here we have to use our keep, change, flip. We're going to multiply by the reciprocal. So -7/4 stays the same, times 4 over 15. We have to flip that around. Now if I look along the diagonals, we see something that we can reduce. So 4 and 4 have a common factor of 4. So I'm going to divide both those by 4. We could also have divided by 9 here on the previous problem, and it would have given us an answer that was a little smaller. It would have given us right to that 87 over 10 in the beginning. So I divide both of those by 4, and now we have -7 over 1 times 1 over 15. I'm multiplying a negative number by a positive number, so my answer is going to be negative. Then we multiply horizontally across, and we end up with 7 over 15, bring over the sign, and we have -7 all over 15.